Welcome to Norton Chemistry. Today we're going to be answering some Haloalkanes exam questions. Feel free to go ahead and answer the questions. I'll put the link in the description and then you can run through the video for your answers. So question 1. This question is about the alcohols A to F shown below. Alcohol A can be prepared by the alkaline hydrolysis of the bromoalkane CH32 CH CH2 CH2Br. The hydrolysis with aqueous sodium hydroxide is shown in equation 5.1. So we're using sodium hydroxide to hydrolyze the haloalkane and form an alcohol. A student gently heats a mixture of the haloalkane and sodium hydroxide for 25 minutes. Calculate the atom economy for the preparation of alcohol A in equation 5.1. So we need to remember the equation for the atom economy, and that is the MR of the desired product divided by the MR of all the product, which in this case is 88 divided by 88 plus 102.9, which when you multiply by 100 gives 46.1% to three significant figures. Outline the mechanism for the alkaline hydrolysis of the haloalkane. The structure of the haloalkane has been provided. Show curly arrows, relevant lone pairs and dipoles, and the product. So when we're doing hydrolysis, it's going to be nucleophilic substitution, because the sodium hydroxide is going to form hydroxide ions, which have a lone pair of electrons on the oxygen, and they also have a negative charge. And nucleophiles are electron pair donors. We draw a dipole on the carbon to bromine bond, and then we draw a nucleophile. And then we draw a curly arrow from the centre of the lone pair of electrons to the delta positive carbon atom. And that causes this carbon-bromine bond to break. So we draw a curly arrow from the centre of the carbon-bromine bond to the bromine atom, showing the movement of a pair of electrons to the bromine atom. And then the product is... And you also form bromide ions. So name the type of mechanism, so it's nucleophilic substitution. The student decides to prepare alcohol A using the same method as in the part above, but using the chloroalkane CH32 CH CH2 CH2 Cl instead of the bromoalkane. State and explain how the rates of hydrolysis of the chloroalkane and the bromoalkane would differ. So the rate of the chloroalkane is going to be slower than the bromoalkane because the CCl covalent bond has a higher bond enthalpy than the CBr covalent bond. So the CBr covalent bond requires less energy to overcome, so hydrolysis can occur at a higher rate. A student hydrolyzes a haloalkane E using the following method. So 0.01 moles of haloalkane E is refluxed with excess sodium hydroxide to form a reaction mixture containing an organic product F. The reaction mixture is neutralized with dilute nitric acid. Excess silver nitrate is added to the reaction mixture, forming 1.88 grams. Organic product F has a molar mass of 74 grams per mole and has a chiral carbon atom. Draw a label diagram to show how the student will carry out the hydrolysis of haloalkane E. So we're doing it under reflux, so we need to draw a diagram for how we do reflux. So we're going to start with our pear-shaped flask, and we'll add labels at the end, and going up into our Liebig's condenser. So we'll draw the water jacket, and then you need to ensure that there is a safe passage for vapours to escape. And then add your rubber tubing for the movement of water, and you need a heat source, so you can just draw an arrow for that. And then label everything up. And remember, the water must go in at the bottom and out at the top to ensure proper cooling. So analyse the information to find E, F and G. Show your working. So let's have a look at the information again. We've got 0.01 moles of the haloalkane reacting with excess sodium hydroxide to form a reaction mixture containing organic product F. The reaction mixture is neutralised with dilute nitric acid. Excess silver nitrate is added to the reaction mixture. 1.88 grams of precipitate G forms. So the first thing we can find out is the molar mass of precipitate G, which is calculated by dividing the mass by the moles, which is 1.88 grams divided by 0.01 moles, which gives 188 grams per mole. And then the AR of silver is 107.9. So if we subtract that by 107.9, that gives us 80.1, which is close to the AR of bromine, which is 79.9. So the halide must be Br minus. Then we can identify F by its molar mass, which is 74 grams per mole. And we know that it's got to be an alcohol with a chiral carbon. So if we say that we've got 4 carbons, if we multiply that by 12, that gives us 48. And then for the alcohol group, you're going to have 17 because oxygen is 16 and hydrogen is 1. So that leaves you with 65. Molecular formula must be C4H9 H9O. And then the only structure with a chiral carbon, remembering that a chiral carbon is one which has 4 different groups attached, is this structure. Because as you can see, this carbon here is chiral because it has an alcohol group, a hydrogen group, a CH2 group and a CH3 group attached. So it has 4 different groups attached. So that is F. And then we can identify E because E is a haloalkane and it must be C4H9Br because it has to be the same halogen as the precipitate G. And then it will have the same structure as F, so it will look like this. Thanks for watching. Be sure to check out my website. I've got lots of resources available, including my A-Level Chemistry notes and flashcards. You can also book a tutoring session. Send me a message and I'll book you in. I've also got lots of other videos on my channel. Check the alcohols exam questions in the top right corner now.